Hi everyone, welcome back to our channel. Today we are going to find the solution for this problem. So here the problem given is a 12 ohm resistor, 6 ohm resistor and 8 ohm resistor are connected in parallel. We need to find out I1, I2, I3. So how to find out I1, I2, I3? It's very simple. So by seeing the problem you can understand that I can write down the I1 as okay. So the voltage at this point is how much? 48 volts. The voltage at this point is 0 volts. Therefore, these two are connected to the same point. The voltage at this point is 48 volts and here it is 0 volts. The voltage at this point is 48 volts. This is 0 volts. The voltage at this point is 48 volts and here it is 0 volts. So by using nodal analysis, so nodal analysis, so I'm going to apply a KCL at this point. So at 48 volts node, I'm applying nodal analysis. What are the entering currents? You can see here the current I is entering. So current I is entering and the current is leaving as I1 and the current leaving as I2 and it is leaving as current I3. So now we need to find out. So first let's try to find out I1, I2, I3. So how to write down I1? Okay. So I1 is equal to, so the current flows from high potential to low potential. The current flows like this from high potential to low potential. High potential value is 48 volts. So 48 volts minus 0 volts divided by R. What is the value of R? 12 ohms. Why? Because the formula for current is V by R. So 48 volts minus 0 divided by R is how much? 12 ohm. So this is of 4 amperes. Let's try to find out the current I2. So how to find the current I2? The current I2 flows across the branch 6 ohm. So what is the voltage at this point, at this node? 48 volts minus 0 volts divided by R. What is the value of R? R is nothing but 6. Okay, so 48 by 6, this is 8 amperes. Next, the value of I3. So I3 is equal to, so the current I3 flows in this 8 ohm resistor. So the current can be written as the formula of V by R. So we can write down the voltage as 48 volts minus 0 volts, which is high potential, minus low potential divided by R is how much? 8. So therefore 48 by 8 is nothing but 6 amperes. So I don't know the value of I is equal to I1. So I1 value is how much? 4 amperes. I2 value is how much? 8 ampere. I3 value is how much? 6 ampere. Therefore I is equal to, so totally 18 amperes is the current. So the values of I is 18 ampere. The value of I1 is 4 amperes. The value of I2 is 8 ampere. The value of I3 is 6 ampere. This is how we had find these values of I1, I2, I3 and I for the network shown below. So hope you are able to understand. The methodology I applied here is nothing but nodal analysis. So before applying nodal analysis, we should apply Kirchhoff's current law. From Kirchhoff's current law, current I is equal to, we have to express in the form I equal to V by R. Hope you understood the content. We'll meet again in the next video. If you feel the content is useful, please like the video, please share with your friends, and if you have any doubts, let me know in the comment section. I will answer your comment. Thank you for watching the channel. So this is a free channel by the name KV Tulasiram. This is a free channel for the development of students and faculty. So kindly support the channel such a way that we can solve more problems. Thank you for watching. Yours obediently Ram.